All right, so today we're going to learn about how to solve a GCF or an LCM word problem. What the words are that are important for us to know which one we're going to use, okay? So which one is on the what? What's the word? Raise your hand, please, if you can tell me what word fills in this blank. Abdul. GCF. And Abdul, it's on the what? Left. This is just a quick reminder, guys, that the GCF is always on the left. It's the factors that we're pulling out when we use that sled. Terrell, what's the bottom one you're going to read? LCM. LCM is? All of them. Okay? And remember, that means that all the factors that are left around the bottom are going to be your LCM factors. Okay? And we multiply them to get our GCF or LCM. So today, we're going to look for some key words that help us know whether we're going to use GCF or LCM to solve a word problem.
Can I use a highlighter?
Sure. You can always use a highlighter. So let me ask you a question. Give me some words you think might help us know we're looking for a greatest common factor. What do you think, Madison? Greatest. Absolutely. If you see the word greatest, you're probably going to find the GCF. Somebody have another word for me. Melina. Maximum. That's the biggest, the maximum. Good. I like that one. Somebody else have another one. Skylar. Biggest. Make sure you guys, as we're writing them down here, that you're writing them in your notes, please. Somebody I haven't talked to yet. Clea.
This is not LCM.
I'm not on LCM yet. Let's do GCF first. Dustin.
Largest.
Okay. Anybody else? Melina. Highest. You also might see something like the most. What are the most number of things I can make? Does that make sense? Those are words that you might see. There are probably others, but these are the most common words. So if you're reading a word problem and you're trying to say, am I going to find the greatest common factor or the least common multiple? We're going to look to this list right here. Those will help us know, oh, I probably need to find the GCF. Somebody give me some words you think might help us find the LCM. Lynn. Lowest. That might work. Somebody else. Let's see here. Who haven't I talked to yet? Dominic. Smallest. Remember, you guys should be writing all these down as I go, please. Kalia. Lowest. I got lowest. Somebody else have one for me. Dustin. Least. Anybody have a different one? Melina. Minimum. Do you have another one for me, Abdul? Smaller. Okay. You have another one for me, Sean? Okay. Lynn, you got another one? Do you have another one, honey? What is it? Fewest. Kalia, do you have another one for me? Shortest, maybe. All of these words are meaning that we're looking for something small, right? Okay, smaller. So they may not all be seen all the time. There may be others. But this is kind of getting us in the mindset. If we see those words, we're probably going to be doing something LCM. Okay? Now let's take a look at the two problems at the bottom of that page, okay? It asks us to circle the key words in the problems that let you know if you need to find GCF or LCM. I'm going to give you guys about a minute. Look through those problems. See if you can find the key words. One of the words we just talked about. Love it. I see a lot of heads down reading. Gabriel, look for some of these words that are up here and circle them. So you're looking for these words to circle. All right. Raise your hand if you can tell me the key word in number 1. Madison. Smallest. We are looking for the smallest number of bags. So if we're looking for the smallest, are we looking for the GCF or the LCM?
The LCM.
There we go. That's what we're looking for. Somebody, you have a question for me, Clea? Okay, hold on. In that same problem? Which word, honey?
Left.
How many will you have left over without anything left over? That may be helpful, but in this case, the best one is going to be your smallest. Alexander, in the second one. Greatest. You got it. Greatest. That tells us GCF or LCM? GCF. Those things tie directly. Now we're going to turn this page over and we're going to go into the back side here and we're going to look at those problems a little bit more carefully. Okay? So I want everybody to look at example number 1. We circled smallest. So we knew we were finding the what again?
LCM.
LCM. All right, now there's a couple ways to find the LCM. We could buy, so let's look at the problem. It says Johnny is making goodie bags that include a lollipop and bubbles. If the lollipops come 4 to a pack and the bubbles come 6 to a pack, what is the smallest number of bags that he can make and not have anything left over? And then how many packs of lollipops and bubbles will he end up having to buy? So let's talk about this. We can do it a couple of ways. Let's look at it as pictures, okay? We're going to keep buying packages until we have 1-to-1 matchups. So if we buy 3 lollipops, that's 1 pack, right? It will only cover 3 of our bubbles. So I need to get to 12, or I need to get to 6, right? Well, if I get to 6, I'll buy 4 lollipops will get me to the 4th bubble. And then I need to buy another pack of lollipops, right, to match up with my bubbles. But when I do that, I end up having extra lollipops. So I have to buy another pack of bubbles. And to get to the end, I have to buy another pack of lollipops. So we'll keep buying until we match up 1-to-1-to-1. Does that make sense, Abdul?
I have a question.
Sure.
How it's 3 buses that he has 4?
Say that again?
He said in the story,
Uh-huh.
he said he has 4, but how he has 3 in the...
So what it says is each of the lollipop packs, when he buys a box, it comes with 4.
Oh.
And each of the bubbles come with 6. And we're trying to figure out how many do we have to buy to match up. Does that make sense? So if we do that, one of the ways to do it is to draw. Okay? Once we do that, we realize, well, I'm going to need 12 of each of them before I finally have the same number, right?
Yeah.
And if I need 12, if the lollipops come 4 to a pack, how many packs do I need to buy? 3. And if the bubbles come 6 to a pack, how many packs do I need to buy? 2. That would get me 12 total. Now, since we know it's an LCM problem, we can also put 4 and 6 on a what?
Sled.
On a sled. What's the common factor that comes out of 4 and 6? Something 2, right? 2 goes into both 4 and 6. Raise your hand if you can tell me how many times does 2 go into 4? Terrell? 2. And how many times does 2 go into 6?
3.
Raphael? 3. Now let's take a look at that. Our LCM is all of them. So I'm going to draw a box around them all. It also makes what letter, guys? An L. And we multiply to get our... Okay? Now look. 2 times 2 is what?
4.
Times 3 is 12. I'm going to make 12 goodie bags. Okay? Now the question is, if I make 12 goodie bags, how many of each item am I going to have to purchase? Well, if I need 12 lollipops total, and the lollipops come 4 to a pack, how many packs do I have to buy?
3.
So 3 packs of lollipops. And if I need 12 bubbles, and they come 6 to a pack, how many packs of bubbles will I need?
2.
2. 2 packs
The sled immediately tells
of
you.
bubbles. Say that again, honey?
The sled immediately tells you it because all of
Yep.
them on the bottom.
Yep, those are your numbers. See that 3 and that 2? They match up with these. Now, they're kind of opposite of what you'd expect, right? These were originally our lollipops, and they came in a pack of 4. We need 3 of those. Our bubbles came in a pack of 6, and we need 2 of those. Okay? Does that make sense?
Yeah.
So you can draw it. You can use the sled. You can use letters to represent each of them until you can get them to match, but that's our goal. Samuel?
We have something that can wipe out. Pen.
No, that's why you're supposed to use pencil in class. Yeah, no, I don't have whiteout for you. All right, the second problem here, I'm going to try to make it a little bit, well, bigger maybe. We'll see. The second problem here says that Shannon is making identical balloon arrangements for a party. Hold on one second. Let me just fix the screen because that's our 10-minute. Okay. Shannon is making balloon arrangements for a party. She has 24 white balloons total and 16 blue balloons. She wants each arrangement to have the same number of each color. So that she wants every arrangement to have the same number of blue balloons and every number to have the same an equal number of white balloons. What is the greatest number of arrangements she can make if every balloon is going to be used? Yes, sir. Let's use our sled method, right? Greatest means we're going to find the what? GCF. So let's put the two numbers, 24 and 16, on our sled. Okay. What's the common factor between 24 and 16, Dominic? 2. Sure, they're both even, right? How many times does 2 go into 24? Gabriel? 12. How many times does 2 go into 16? Come on, somebody I haven't talked to yet today. Matt, Lauren, I haven't talked to you yet. 8. All right, look at 12 and 8. Do they share a common factor?
Yes.
Yeah, Daisha, what do they share? 4. Sure, let's do that. How many times does 4 go into 12? Anastasia? 3. And how many times does 4 go into 8, Skylar? 2. Now let's look. Do 3 and 2 share any other common factors? Nope. So we know we're done. And GCF is?
On the left.
So here's GCF. We take those two factors. Yep. And so you get 8. Now if I know there's going to be 8 arrangements, okay, there's a couple ways I can figure out how many blue and how many white. Let's look at that. So we could do it this way. I'm going to make 8 arrangements. How many white balloons do I have total?
24.
So I could do this. 1, 2, 3, 4, 5, 6, 7, 8. That's the first round. And I can keep counting until I get all 24 balloons given out. And then I can do the same thing with the blue. Or I can look. If I'm going to make 8 arrangements, how many groups of 8 are in 24? How many groups of 8 are in 24? 3. So I'm going to have 3 white balloons in each group. And if I have 16 blue balloons, and I'm dividing it into the 18 bouquets I'm going to make, how many blue balloons will be in each one? 2. And 2 blue. Let me say that again because I don't want anybody to be confused. If I'm making 8 bundles of balloons, and I have 24 white, there's going to be 3 groups of 8 in those 24. So there'll be 3 white balloons in all my bundles. And if I have 16 blue balloons, and I'm going to break those into 8 groups, there'll be 2 balloons in each of those 8 groups. Does that make sense?
Yes.
Okay. Here's what we're going to do because we're just about out of time. Do you have a question on this, Samuel?
Yeah.
What's your question, honey?
When you were doing this, all the time I didn't know what do you do with it, like the scale? I'm like, and now that you tell me, I just wrote here. I'm like, oh, I didn't know. I know
And
what
your
I'm
notes
doing.
are beautiful. Good. Well, those notes would have been great the first time we gave them, and that would help you too. All right, listen, I'm not done recording yet. Listen carefully. Tonight, okay, tonight, I want you actually to try page 12. It's going to be word problems just like these. Just try them. We will go over them. What, honey?